Can you actually now turn off your cameras so that I can share screens with you, and so that we do not override the system? If you can keep yourselves muted as well and come in when you want to talk, that'll be fine. Let me call up the camera and address one of the homeworks, because although it was probably well done, and this is the last homework you'll probably do in this book, actually, well, sorry, it was classwork, wasn't it? Many of you did not do it adequately. I won't say incorrectly, but not adequately. So Jordan, I need you to listen, and a lot of you others need to listen as well. I did say in the video and also in the lesson with this that you should include the data in your answer, in your response, because that data inclusion is evidence of how you're going to use it in order to give a correct response. So I would have written down, I'm sure Ella did this, I think Ella was memorable because I just remember doing it. If you write down boys' median shoe size equals 7, girls' median shoe size equals 5, boys have larger shoe sizes on average. Hudson, take your camera off because it's going to kill the video. All right, we can't have too many videos in the background. Thanks, Hudson. All right, have you got that? So you're meant to state the data and then give a statement which, okay, Christian takes off, and also you need to give your conclusion once the piece of data has been stated. So you may not have the book in front of you, that's page 248. It keeps going out of focus. Now, we did this one as well in the lesson, I remember. So the temperature of Bath and Wick are measured every day. Bath's mean temperature is 17, Wick is 29 degrees. So you just write down Bath equals 17 degrees, Wick equals 29 degrees. What conclusion can you draw? It's very simple. The average temperature in Wick is hotter than the average temperature in Bath. There's no talk about range or consistency here. It's hotter there than there on average. Let me read the third one. You need to mute yourselves so I don't hear you, and then come in if you want to speak. So 2 teams took part in a table tennis competition. They recorded how many points each team scored, the range of points. Now, this is about range. It's not about mean or median or mode. It's the range. So the range points for the red team is 16 points. The range points for the blue team is 3 points. What conclusion can you draw? So how about you write down red range equals 16, blue range equals 3, and that's the data you're about to reason with. What conclusion can you draw? The red team's scores were less consistent. The red team's scores were more spread out. The red team's scores were more varied. Okay? Or the other way you can say it, the blue team's scores were more consistent. The blue team's scores were less varied. Something like that, okay? So you need to have the numbers and you make a statement. That's it, it's just one sentence. Now question 4, its extension for a reason, is giving you 2 things to think about. So before I would do this question, I will write down the data. Mean dog's weight equals 32 grams. Mean cat's weight equals 4 kilos. Sorry, they're kilograms, aren't they? Sorry, I can't really see. Yeah, dog's 32 kilos, cat's 4 kilos. And then give your conclusion. So you don't mix up ranges and actual masses or weights. So what can we conclude? Dogs are heavier on average. Finished. Cats are lighter in weight on average. Finished. All right. So any one of those 2 statements would do fine. Now we can talk about their ranges. So dog's weight range equals 45 kilograms. Cat's weight range equals 0.5 kilograms. Now we're going to state their conclusion. And the conclusion is dogs' weights are more varied. The weights of dogs are more spread out. The weights of dogs are less consistent. Yeah, you may get a very little dog that's about as big as a fat cat, and you get a huge dog that weighs as much as 4 people. All right, so 45 kilo weight range, less consistent. Or you can go down the cat route. The weights of cats more consistent. The weights of cats are much closer together. The weights of cats are less varied. When you see a cat in the street, or maybe your own cat, it doesn't look hugely different to any other cat in terms of the amount of cat you've got sitting in front of you, yeah? So we know from reality that cats' weights are far more consistent than weights of dogs, which can be as big as an overgrown rat or as big as a horse. I exaggerate only slightly. But there you go. That's the homework, and that's the kind of detail I was looking for. Now you may notice on Show My Homework that I've got 3 sessions which are essentially revision sessions that take care of Unit 6. Now of course I can't revise everything with you on screen. It would just be too long and too unnecessary. Let me just give you an overview where we've been. Have you seen this before? You can. Yes. Okay, that's probably Ayan. Sorry, that's probably Viraj. So there we go. So quick bit of revision. Probabilities can be expressed as fractions, as decimals, as percentages. These words like impossible, unlikely, it's very low grade. We don't want to bother with that. However, if somebody said the probability that such and such will happen is certain, well, that's going to be a 1. So if it's certain, it's 100% going to happen. Nothing you can do about it. If it might or might not, then it'll be evens. If it's above even but not certain, then it's likely to happen. So again, this you wrote down in your books. This is where your revision begins. All right, so that's a bit of probability, the probability scale. Then we did an experiment on throwing the dice around the room, made a lot of noise. This is all about conducting an experiment to see if the probability of landing on a 6, for example, really is 1 out of 6, or the probability of landing on a 3 really is 1 out of 3. Did the experiment fit with the theoretical probability? And some has thought, actually, I think my dice is biased because I didn't get 1 out of 6. I got this, so I think I threw too many 4s. I think my dice is biased towards 4s. Do you remember that experiment? Yeah. Okay, thank you guys. So you sort of remember it. Good. So obviously I don't want you to remember the figures in your table, but understand that an experiment is supposed to confirm or contradict what you'd expect would happen in theory if the dice was perfect every single time you threw it. All right. Yeah, so this is what we did. We calculated our relative frequency, and I said, what's the theoretical probability of getting every single number? What's the probability of throwing a 1 in theory? 1. Thank you. What's the probability of throwing a 2 in theory? There are not 2 2s. They're all 1 out of 6. Is that all right? Hi, Ethan. They're all 1 out of 6. So let's just keep going. All right. Don't ask about that. Don't know what that is. So this you would have seen in class, but we didn't use it. We didn't need to use it. We did our own experiment. What I think they're doing is they're throwing a white die and a red die, and they're listing all the combinations of possible outcomes. Let me ask you a question, since it's here. What's the probability of throwing a 6 and a 6? Somebody open up and speak, but identify your name. What's the probability of throwing that double 6 right there? How many combinations, how many outcomes do you see? How many combinations do you see? So what's the probability of getting a double 6? Thank you. Is that you, Jordan? Okay, good. Identify your name, because I've got to try and remember what your voice sounds like without the picture. Yeah, 1 out of 36. What's the probability of scoring 3 or less as a total? What's the probability of scoring 3 or less as a total? 3 out of? 3 out of? Yeah, there's 36 combinations here. Let me just write it here. And the probability of scoring a total of 3 or less, well, that's 3. That comes to 3. That comes to under 3. So I've got 3 combinations out of 36, and we never bother to simplify for GCSE when it comes to probabilities. You leave it as it is. What is the most common? What is the modal total score? I'm combining lots of topics using my words. What is the modal total score? Now you have to think, there's a lot of data there. Sure, come closer then. What is the modal total score with 2 dice? I'm trying not to translate it into Walthamstow English just yet, but I will do. What does modal mean? Very, very good. Now, what is the most occurring total I could possibly get when throwing 2 dice? Damn, you have to do some math now. What's the most common total that you can see there? Ah, you've misunderstood the question. Misunderstood the question. Thanks, Jordan, for that. But there is a most common total. You're not hearing my word total, Jordan. What's the most common total that you see? Okay, now I'm seeing it. The most common total is 7, 7, 7, 7, 7, 7. 1, 2, 3, 4, 5, 6. There's 6 ways of getting a total of 7. Can you see that? Okay, so there's 1, 2, there's 6 ways of getting a total of 7. That is the most common total that you would get when you throw 2 dice that are fair and unbiased, all right? Everything else is less than 7. What about getting a total of 10? Well, there's 1 way, there's 2 ways, there's 3 ways, and that's your lot. 7 is the winner, all right? There are 6 ways of getting a total of 7. Right, I can't quite do that. There you go, that's them, all right? So let me move on. We're doing a little bits of revision and little bits of thinking. So I need to hear other people speaking. This is for Hudson because he likes this. So there you go, Hudson. 1 more, 2 more. There you go, done. Let's move on. Yes, we didn't make use of that. We didn't need to. We did I remember we did a lesson on these little charts and we spoke about them and cookies and what have you. So you're all pretty good at that. That's me working out how many people I think 120 degrees represents. So 120 over 360, there must have been 360 people in the question, and that comes to 120 people. We've done this in preparation for doing our pie charts. That's even more calculations. Again, you don't need to write this down, of course. That's me doing even more calculations and going over a piece of classwork. And that's us doing our pie charts. So I don't want to go this far in the first session. So let me just reduce this down and call up the book. I've got the book in front of me, and I want you to see the book so we can talk together about what you should really do at home, because I'm really preparing you for Unit 6 assessment. So that's the baby work with the baby words. These are silly questions. These are proper questions, all right? So we talked about relative frequency. Look at Abigail. No, don't look at Abigail. Let's look at this spinner. Can I have a reader, please? A spinner with 4 sections. Read to me. Viraj? Okay. All right. So at least I don't have to add up the frequencies. At least they told me it's 100. That helps. Estimate the probability of getting a 1. What's the probability of getting a 1? Nope. Well, yes, only because it's out of 100. I prefer 49 out of 100. It's safer. Because if you suddenly call that 26%, for example, in question 3, that may not be 100 total. We'll see in a minute. So, this question goes to Krish. What's the probability of landing on an 8? Sorry, landing on a 3. No, 8 is not a probability. 8 is a number. Thank you. Did you hear him, guys? 8 out of 100 is a probability. So a probability, Krish, is not just a number. That is just the outcome. But the actual probability has got to be a fraction, a decimal, or a percentage. So you need to revise that. I'm not going to do question 3 because it's going to eat up a lot of time us adding it all up. But anyway, if I wanted to work out what the probability was of landing on a 6, how would I do that? So somebody teach me how to do that. Okay, talk to me. Sophie Stanton, you got brains, talk to me. If I want to work, yeah, talk to me. Well, in order to work out probability, what 2 bits do you need? That sounds like the same thing. The number of times it's happened and the total frequency for the whole experiment, yeah? So Sophie, how would you work out for this question here with Abigail, how would you work out, or talk to me, how to work out the probability of throwing a 6? It's just one short sentence. Somebody help her out. What's the probability of landing on that 6? Is it actually 100 there? Because I've not counted them. Is it 100? What is it then? Okay, so that would be 50 out of 100. Sophie, can you hear me now? Okay, this is what I want you to say. The probability of landing on a 6 is 15 out of whatever the total is. Is that okay? Okay, so start revision. I'm done with that. I'm not going to go beyond probability. Let's see what's next. Oh, theoretical probability. I think I'll do question 2. What is the total number of possible outcomes on that spinner? I can see 6 sections. Who was that? Thank you, Sophia. That's lovely. So therefore, what's the probability of actually landing on a 3? You can see that I can't. Oh, that's lovely. What's the probability of landing on a 3? Thank you. It's definitely 1 out of 6. What's the probability of landing on a 2? Yep. I've got 1 there, 2 out of 6. What's the probability of landing on an even number? 3 out of 6. And whoever said half, don't bother simplifying just in case you're wrong. 3 out of 6 is brilliantly good, all right? Unless the question asks you to simplify it, in which case they're testing something different. They're testing not your probability, but your simplifying skills. Okay, so that's page 220. That'll do. What's all this about? Oh, this is important. Yeah, the chance of things happening and not happening. Right, I'll read you. This is page 222. Number 1. It says the probability that I will receive a parcel today is 0.6. What is the probability that I won't receive a parcel? That goes to Hudson. Hudson, are you still here with us? Yeah, you'd have to, because Hudson, I don't know where he is. Carry on. Okay, so back to Viraj then. He seems to be group leader. So what's the probability that I won't receive a parcel today? Correct. If I'm going to receive something, 0.6. If I won't, 0.4. There's nothing else in between. It's either I will or I won't. Ben travels to work by train each day. The probability that he catches his train is 0.9. What's the probability that he does not catch his train? Call it 0.1. The probability that the train is going to be late is 0.2. What's the probability that it will be on time? 0.8. You've got it. You've got it. This next part is just listing outcomes. A bit like I showed you with the dice table. That's all it is. And then what have we got at the end? A bit more probability on listing outcomes. I think I'll do this question here. So a coin is tossed and a fair four-sided spinner, boom, is spun round. Copy and complete the table. What does H1 mean in this story? That goes to Chioki. What does H1 mean? Yes, you're first since you're quick. Who are you? Okay, Ian, thank you. What we got? Yeah, I flicked ahead and I landed on one on the spinner. What does T4 mean? Louder, please. Tails and 4. I flicked on tails on the coin and my spinner landed on 4. What would go here, Chioki? Is that you, Chioki? Can you speak only? What goes here? Okay, you've understood it. Thank you. All right, and really, that's the end of basic probability. All right, that's that. Then the next part is statistics, which is section 18. So my plan was today was just to alert you that there will be a Unit 6 assessment. I'll send it to you in part.